X and Y relations. That means first comes training and then testings. I have put here testing and training in such a way that the people should understand what is in by testing and training. So when the training is given between the input X to get a Y, the same thing should go with the testing phase. If a new input X is given, then it should also produce a output Y. So in the initial phase, this is what I have been I'm going to express to you in terms of a testing and training. But in a real sense, this testing and training you will understand more in detail in my next slides, where this testing and training is being differentiated in terms of data sets. Now here let us take the training and testing in terms of a single feature. Now if you try to see the previous slide, I have given a features with given a multiple features x1, x2, x3, and I have not here made any terms, only stated that if the training is given between x and to produce a y, under the testing case also the x will produce a output y. So that is what a normal human being also does, and a machine should also perform, because in the human as a child goes to school, learns the instructions, and thereby it will able to know based on this instruction or based on these examples. If the question is being put, the answer will be output y. The same thing is that in the case of a machine, based on the training, if the given x, the y is if it is producing. Under the testing case, for the given x, it has to produce a y. So we take the one of the sets of the x where x is being considered for the entire data set. This x, complete x, is an x data set. Now in the x data set, we are dividing that one into two layers, that is the upper layer and the bottom layer. Now in the case of a upper layer, we term this one as a train sets, and in the bottom side we termed it as a x test. So that means x data set is used for the x train. Similarly, there is a y train I have to. That means a data set related to the related to the y is used for the y train. And here also I have put there is a x test. That means x data test data set is used for the test, and y data set is used for the test. Now what is the difference between x and y? We will see in the next segment. Now you have to assume that time being I have segregated this one as a x and this one as a y. But in a real sense, this entire sheet is nothing but a data set where this x is there and a y also there. But we are making a demarcations between the x group and a y group. So that means x train is there and y train is there, x test is there, y test is there. So this is the learning phase, and this is nothing but the verification phase or a testing phase. Now let's see the terms, what is meant by features and labels. Now if you want to understand this particular features and label, because this is the very important concept to understand the machine learning. Now if you try to see across this particular example in the form of a table, I have written here the feature, a non-target attribute, and label is a target attributes. As I have told to you here, I shared here is that this is complete is a one single data set where x is one group and y is one group. In the same way, this is a x group and this is a y group. Now let's take an example like for a child is students is learning this question. So for a teacher is giving an exam, teaching in this way that for a given question, this is the answer. For a question 2, this is the answer. For a question 3, this is the answer. That means for this answer, this is the question. For this answer, this is the question, this answer. So that means that the students will able to understand the particular logic based on the questions and answer. So this is what we termed as a non-targeted attribute and targeted attribute. So once the students understand the end question, the students will able to understand the and able to understand the end answer. The students will be in a position to respond immediately. If any questions comes, the students knows that okay, this is the appropriate answer because of the learning mechanisms. Now let's take the similar logic is being applied for the machine learning, for making the machine to learn also in this way. First, that is what we term in terms of a machine. So any questions that is being put across this one, that is a future, and in the this in the future, this is the question is an attributes. Now answer is also an attribute, but that we termed it as a target attribute, because based on this this is the target whatever for this question, this is the answer is our target, and this is termed as a label. So anything which is related to the X in the previous slide, that is we termed as a future, and anything which is on the right side, that is we termed as a label. So time being, you understand based on this concept. Now let's see this example to understand more about it. Here a particular data sheet is being taken where user ID is given, gender is given, age, height, weight, duration, heart rate, body temperature, calories. So based on these data, the machine has to train. So how the machine will be trained based on this? So in this case, again the same thing is that the machine should know what is meant by future and what is meant by label. So here if you try to see is this that every content in this case is attributes. All are attributes. So there are 9 attributes are there. So among these 9 attributes, you can select any one of the attributes as a target attributes, and the remaining as a non-targeted attributes, or in another way you can select any targeted attribute that is termed as a label, or any and the remaining non-targeted attribute is termed as a future. So that means these wherever the future attributes comes, that comes under X, and wherever the targeted attribute or the label comes, that is considered under the Y segments. Let us take one example. Here is given that gender X2, that is gender, height and weight. Under these 3 things is being given, gender, weight and height and weight. So this is termed as a one section of attribute. Based on these attributes, that means there are 4 persons, 4 gender, 4 height 4 persons gender is given, 4 persons height is given, 4 persons weight is based on these attributes, these 4 persons calories need to determine. So if the person's calories to be determined based on these 3 attributes, then these 3 attribute is termed as a future, and calories is been termed as a label. So that's why I put it. So this is a label, and this is these 4 terms is considered as a future or a non-targeted attribute. Another example: suppose you are selecting a different future, and there is nothing like that. You should select the something on the one end. You can take another example. You want to treat this heart rate as a label. That means targeted attributes. and you want to select this gender, age and weight. Gender is second, age is given, and the weight. Based on the gender, age and weight, you have to determine the label. So here the gender, age and weight is considered as the future or the non-targeted attributes. And what about the label? Label is considered as the targeted attribute, and here in this case the heart rate is considered as the targeted attribute. So this is what exactly means by the future and labels. So always you should keep it in your mind. Label is the one where you are looking for the target, and the future is one that is given as an inputs or the attributes of the given data sets. Let's see further to understand these futures and labels, as well as we have used the word training and testing, or test and train data. Now let's see this particular statistics. This statistics, it has been taken from the COVID-19 data sets of COVID-19 India data sets, where you can see that different attribute is given: serial number, name of the states, and the different novel corona diseases attributes, like a confirmed case, discharge case, death case. Now if you try to see this particular database, as I told to you, is that this entire data set is being considered as a particular form of a combinations of two components, that is the X components as well as the Y components, where we are given the terms train and set. So as I told you, this the entire is a data set where we are dividing this one into two part, X part and Y part, and then we are also segregating between X and Y. So the upper part is a train part and the lower part is a test part. So this train and test part you should remember, and based on this train and test part we will go further to understand what exactly that means. So if you try to see this particular slide, this entire slide of a data set is being divided into two parts, just like here it has been divided into two parts. This line comes up to here, means it is two parts. So the upper part is being treated as a larger data sets, where this is a trained non-targeted attributes, that is the upper part, and the lower part is also a non-targeted attributes, but this is considered as the trained data sets, and the lower part is termed as a test data sets. That's what we train data set and test data. So this is a trained data set, this is a test data set. Now as we have seen in the previous case, the future and the label has to segregate. What we have decided is that we are taking a case of a COVID-19, is that we have to find that among these 32 states, which state is having a highest death rates. So that is what we have to identify, and so based on that conditions we have to determine our next statistics, or the government will be taking a test, or the medical professionals will be taking its own statistics on steps. So here what we have done, the first part is dividing this data set into two parts, upper part, lower part. Upper part is a train part, lower part is a test part. This is clear to all of you. Then what we are going to do, we are going to find what is the exactly the label as well as the future. So label we are considering as a death, because this is our targeted attributes, and this is our future for the test. So that is known as a test and train data. So anytime you see the data set, either you can go with the 80:20, 80 train data set and 20 test data set, and there is a conditions for that one. So this is not the point of a discussion with respect to the ratios. Rather you should understand that train data set is being taken nearly 80%, and the test data is being put for a 20%. So based on the trained data set. Again, apart from the horizontal bifurcations, we did a vertical bifurcations where the one vertical bifurcation is being done for the targeted attribute, which is a label, and the other side non-targeted attribute is a futures. So we are going to the next segment. We are taking these figures, this figure which is there, and going further. Now if you try to see this one, what we have done is that since it is a machine learning, so we are using a machine learning concept over here, and we are trying to train these particular machines based on the conditions of these data sets. Now if you try to see this particular block diagram, here in this particular block diagram, I have put the previous figure. Apart from that, machine learning, model, y-test, then there is a testing is being compared, and just like a comparators between this y and this is y. I can take it this one as a y dash. It is a y dash. This is a y test. This is a y dash test. You can take it. Now, what we are going to do is that let's go back to we are first taking the test part. Test part is the 1 to 25. So this is the test part. In the test part, these segments, that is 1, 2, 3, 4, the 4 attributes we are taking, that is a x, and what is this target? As I told to you in the previous case, this target is nothing but a y. So this is y, these 4 are x. So that is what I have shown. The x trained data set is being given to the machine learning, and the y, that this is a future and this is a label, the y trained data set is being given to the machine learning. Now the machine learning is using algorithms to run maybe a linear regressions or a KNN algorithms. So based on that machine learning algorithms, it will try to take these two inputs, and that is nothing but this is a input, that is x, and y is an output. And because you know, I have given an example here is that this is the input, this is output, question and answer. In the same way, this is an input, this is an output. The input and output is given to the machine learning algorithms. This machine learning algorithm will take this input and try to produce a model. Now when this particular model is being created, that means the system will able to determine the output based on these number of inputs. So you can see that this number of data input of x and y, the machine could able to produce a new model. Now in the machine learning, what we do is that we are going for a testing phase. Testing phase, where is there? This is a testing phase, that is the down portions testing phase. In the testing phase, we do a little different things. What we do is that since this x is nothing but a non-targeted attribute or a test data, this data is there, and for this data, this y test is indicate that for a given this input, this is an output. That means we know all these questions and all this answer. In the same way, for this given test, we know the output. But what we does is that in the model, we give only the x input, that is a x test data as an input, and we try to produce the we try to see that what the model is going to produce. So model in the the output of the model is y dash. So as I told you earlier, this is a y dash. Y dash is the output. Now whether this input and output has any relations is there or not, because if the machine is once the machine is being trained, then the machine is being determined based on the performance. So the model that is going to see that if the model is accurate or a good or having a good design, then automatically what is going to do, For a given X input, it will definitely go to produce a Y output. But I was telling that Y dash test. Y dash test is that because this model will produce a different output, because we are not giving a Y test as an input. So for a X test, it is going to produce a Y test, Y dash test. So under these conditions, the model is whether it is a good model or it is having any performance error. That if we want to know or to determine, we want to compare the Y test output with the Y dash test output of the model. If this Y dash test is equal to Y test, then it indicates that this model is 100% accurate, and its accuracy is 100%. And if there is a variation in Y dash test as compared to Y test, then we term that the accuracy has been affected based on the model, because the model is being determined based on this machine learning mechanisms. So when Y test data is the actual data, that is what I told you, because this data is known to us before we are going to put for the test. For this text, this Y test we are known, so that's why actual data is there. Whereas Y test is, or a Y dash test is a predicted data. So if the actual data is same as predicted data, then we say that the model is 100% accurate. Otherwise, the model is having a error. So this is how the model is being produce a training as well as testing phase. Finally, here I am putting a validations. So it is the same thing, is that the entire data set is being divided into two parts. Let me summarize. Entire data set is being taken and it is divided into two parts. Upper part is a test. Here the test part is given and a train part is put across. Normally we put the test part larger number, so here based on the figure dimension you should not go. It is think that this is if it is a upper part is a test part, lower part is a train part, or you put it upper part train part, lower part test part, no problem. Now that is the division of the data set. Then there is another